Good morning. Today I will be reviewing the 2023 paper that is textile fiber production of biopolymer and so published in Polymer Review. This article focuses on a specific class of natural polyester called polyester, like this, yeah, written. So the next is the while many of us are familiar with PLA, they also highlight on page 3 that PHAs are superior for medical use because they are produced naturally by microorganisms, making them highly biocompatible. The core argument introduced in page 2 is that while 3D printing is popular, textile-based scaffolds like woven or knitted structures are actually better at mimicking the hierarchical structure of native tissues like bones and muscle. Okay, so the review examines how we turn these raw polymers into usable textile fibers, focusing on melt spinning and wet spinning. As it on page 3, PHAs are notoriously difficult to process because they have a very narrow processing window. Their melting temperature is dangerously close to their thermal degradation temperature. If the heat is slightly too high, the polymer breaks down. Furthermore, the authors note a major research gap on page 4. While melt spinning is well documented, we currently lack the detailed data needed to make wet spun PHA fibers as strong as and reliable as they need to be for clinical use. A key insight found on page 4 is that fibers are the building blocks of medicine. By choosing the right textile architecture, we can control porosity and strength. For example, the authors point out that human tendons require a load-bearing capacity of roughly 150 MPa, a strength level that can be achieved through specific braiding techniques. One of the most fascinating points found on page 7 is that PHAs are piezoelectric. This means the scaffold can generate a small electric charge when the patient moves, which has been shown to actually stimulate bone and nerve regeneration. This transforms the implant from a passive plastic piece into an active medical device. The authors conclude on page 2 that two hurdles remain. First, we need higher purity standard for PHAs to avoid immune reaction. Currently, only one type, PP4HB, is widely approved. Second, we must master their complex crystallization behavior to ensure fibers don't become brittle. Ultimately, this article provides the roadmap for moving away from simple implants towards more textile scaffolds that can truly regenerate human life.